In this video, we're going to look at the mechanism of breathing. Before we start, it is very important to understand the concept of gases and pressure. The rule to know is that gases travel from an area of higher pressure to an area of low pressure. So it's similar like diffusion. Gases move from an area of high pressure to an area of low pressure. Anyways, what is the mechanism behind breathing? Well, here I'm drawing a guy with his respiratory tract, the nose, the mouth, the larynx, the trachea, the bronchi, and the lungs. Here are the lungs. Surrounding the lungs, we have visceral pleura, which is a type of serous membrane. Then we have another pleura around it called the parietal pleura. The parietal and visceral pleura are actually part of the same serous membrane. It just folds on itself. But we don't have to really understand that for this video. In between the visceral and parietal pleura, we have what's called the pleural cavity. And it's important to know just the names of these three when dealing with the lungs. Now, these things I'm drawing around the right lung here partially are the ribs. Connecting in between the ribs, connecting the ribs, we have muscles known as intercostal muscles. And we have three intercostal muscles. These intercostal muscles are muscles used for respiration. We also have another important muscle used in respiration, the one you probably all know about, called the diaphragm. So the two important muscles for respiration are the diaphragm and the intercostal muscles. Now that we know the muscles, let's learn about the pressures. Now, outside our body, there is atmospheric pressure, which we measure to be 760 millimeters of mercury. In our lungs, our actual lungs, there is pressure that we call intrapulmonary pressure, which complements the atmospheric pressure, so it's balanced at 760 millimeters mercury. We also have this other pressure called the intrapleural pressure, which is the pressure in the pleural cavity. Now, to make this video really simple, we will focus only on the atmospheric pressure and the intrapulmonary pressure, which will try to balance out. And remember the rule that gases, air, travels from an area of higher pressure to an area of lower pressure. So the air, the gas here, for example, outside, will only travel into the lungs when the intrapulmonary pressure drops. So how does the intrapulmonary pressure in our lungs drops? Let's have a look. So again, just quickly here are the ribs surrounding the lungs. And here are the intercostal muscles that run between the ribs. Then you have the diaphragm here. The intercostal muscles and the diaphragms are the two important muscles in normal respiration. Then you have the two important pressures, the atmospheric pressure, which is 760, and the intrapulmonary pressure, which in this case is also 760. So the atmospheric pressure and the intrapulmonary pressure are balanced. There is a difference of 0 millimeters mercury in respect with the atmospheric pressure. One more thing to know is the intrapulmonary volume, which is basically the volume within the lungs. Now, if the intrapulmonary volume changes, this would mean that the intrapulmonary pressure will change as well, right? Because there is a relationship between pressure and volume. And this is also important to understand. Now, before we continue, the ribs I have drawn here are a bit misleading because most of the ribs actually wrap around the lungs, correct? So if we were to look at this diagram from a superior view, it can look something like this. So here is the back, the vertebrae, and then the ribs, which actually circulate around the whole lungs and connects to a bone in the center known as the sternum with cartilage. And then And then in between the ribs, running in between the ribs, we have the intercostal muscles. And of course, in the center, which I have not drawn, we have the lungs. So let's look at inspiration, the mechanism of inspiration. So here again, we have the lungs and the pleura, and then we have the diaphragm below the lungs. What happens in inspiration is that the volume within the lungs will actually increase. So here, this is due to the constriction of the two important muscles, the intercostal muscles and the diaphragm. During inspiration, the diaphragm contracts and moves down. This will allow the intrapulmonary volume to increase. Because the intrapulmonary volume increases, the intrapulmonary pressure will decrease to about 759 millimeters mercury. So in respect to the atmospheric pressure, there is a difference of negative 1 millimeters mercury. The intrapulmonary pressure is 1 below the atmospheric pressure. And because we know the rule of gases, the air, the gas, oxygen, will flow into the lungs down its pressure gradient from an area of high pressure to an area of lower pressure. And so after inspiration, we have automatically expiration when we breathe out air. What happens here is that the intercostal muscles and the diaphragm muscle will relax. The diaphragm will move back up to its original place, and this will cause the intrapulmonary volume to decrease again. A decrease in intrapulmonary volume will mean that the intrapulmonary pressure will increase. And the intrapulmonary pressure will increase to 761 millimeters mercury, 1 above the atmospheric pressure. And so knowing the rule of gases, gases will move out from the lungs into the air outside, down its pressure gradient. Hope that makes sense. Then from expiration, we have inspiration again, and the cycle continues. Of course, we have some voluntary control over our breathing, and we can hold our breath. But this only lasts a short time before our brain overrides our voluntary control. Now that we get the gist of what's happening in inspiration and expiration, let's put all of this together and look at the concept of the mechanism of breathing from different angles. So here I'm drawing the superior view of the ribs, and we're looking at what happens to the rib cage essentially. And here I'm drawing the side view of a person with his ribs and lungs. And so here we have the diaphragm in dark red I'm drawing here. And here we have the intercostal muscles in between the ribs. So in inspiration, the diaphragm will descend and the intercostal muscles will contract like so. And this will essentially expand the rib cage, and the rib cage will rise. This will cause the thoracic cavity volume to increase. And an increase in thoracic cavity volume will mean that the intrapulmonary volume will also increase, which will lead to a decrease in intrapulmonary pressure. A decrease in intrapulmonary pressure means that gas can flow from a higher pressure to lower pressure, so from the outside to the inside, so gas flows into the lungs. Then we have expiration. In expiration, the diaphragm will rise and the intercostal muscles will relax. And so the thoracic cavity will decrease, will shrink, and the rib cage will descend. So the thoracic cavity volume will decrease. This will cause the intrapulmonary volume to decrease, and which will cause the intrapulmonary pressure to rise, to increase. And so gas will flow out from the lungs, from a higher pressure within the lungs to a lower pressure outside of the lungs in the atmospheric pressure. Hope that all makes sense, the inspiration and expiration mechanism of breathing. Of course, it's important to note that you have also accessory muscles that are used in breathing. So these accessory muscles used are the sternocleidomastoid muscles and the scalene muscles. Anyway, I hope you enjoyed this video on the mechanism of breathing. Thanks for watching. Bye.